Okay. Okay, so we're about to wrap up the first week of our second 6 weeks. Tomorrow you'll get your next focus activity, and with any luck, we should be able to wrap this up as well. Don't forget the big idea. A couple of these still pertinent. Tomorrow, if you need a waiver for this or another weighted course for the first 6 weeks, those are due 10 a.m. tomorrow to Marcia Edwards, Mr. Young's secretary. And about a week and a half, we're going to be looking at our first exam, okay, on Monday the 8th. So a week from Monday. All right. Well, let's get going. What do we got here today? Engineers in the ancient world discovered ratios within right triangles as they learned fundamental engineering skills. The secrets and patterns necessary to understanding circles and spheres helped in the development of trigonometry. Our chapter begins the journey into trigonometry with an introduction into angles and their measures. So as I said, there's going to be a lot of vocabulary coming at you today. So first off, an angle is determined by rotating a ray about its endpoint. So you might recall from geometry that a ray is just a line segment that goes forever in one direction. So we got this diagram over here. The vertex is the endpoint of the ray. Okay. The initial side is the starting position. Whether you rotate clockwise or counterclockwise, we begin in the initial position. Okay. And the blank side is the position after rotation. Well, that is the terminal side. Okay, that is the terminal side, is the position after rotation. So whether you're moving a certain number of degrees or a certain number of radians, as we're going to go ahead and talk about tomorrow, where you stop, that's your terminal side. Okay, now let's talk about standard position. Angles that are in standard position are placed on a coordinate plane with the vertex at the origin, as shown here, and the initial side on the positive x-axis. Okay, so wherever you start is the initial side, but if that initial side happens to be on the positive x-axis, that's what we call standard position. Now, if you rotate counterclockwise, what kind of angles do you think we're going to have? Starts with a P. Perfect. Okay, they could be perfect. Position for positive. Positive angles are going to rotate counterclockwise. So what kind of angles are going to rotate clockwise? Negative angles. There we go. Negative angles. So it's not that we're saying the angle itself is negative. What you're going to see, especially as you move up into calculus, the negative simply tells me direction. Okay, so you're going to have the same angle measure. It's just rotating clockwise instead of counterclockwise. Okay, so our first type of angles that we want to get familiar with are what we call coterminal angles. Two angles in standard position. That means the initial starts where? On the positive x-axis. Okay, standard position that have the same terminal side are what we call coterminal angles. So put simply, they're angles that have different measures, again, whether degrees or radians, but they have the same terminal side. So no matter how you rotate, they have the same terminal side, the same stopping point. Okay, we can find an angle that is coterminal to a given angle by adding or subtracting one revolution. Now, we're just going to be talking in degrees today, so what is one revolution in degrees? Yeah, 360 degrees, right? So any given angle has, and it should be infinitely many coterminal angles, and you'll see how in just a second. So here's an example. Let's say we have an angle measure beta is 36 degrees. And it's coterminal to all the following. Well, let's go ahead and first start with this. 36 degrees would definitely be in what quadrant? No, not the second. In the first quadrant. Let's go ahead and map this real fast. If we start at 0 degrees, we're beginning here in standard position on the positive x-axis. Each quadrant would represent how many degrees? 90. Okay, so here I have 90. Then I would have 180. What's 3/4? 270 until I get all the way back around to 360 again. All right, so 36 degrees will definitely be in the first quadrant. So let's say 36 degrees right here. All right. So see, I started here. I began to rotate where the angle stops. Remember, that's what we call the terminal side. Now, coterminal angles will have different measures, but they have the same terminal side. All right. Typically, what I'm going to ask you is to go for one positive and one negative. All right, let's look at a positive first. Okay. So let's say we start here in standard position, and I rotate up, but if I stop there, what am I at? 36 degrees, right? So what it's saying is that you can find coterminal angles by adding or subtracting one revolution. Well, that just means you go around once more. So from here, I'm going to swoop all the way back around. See, that's the same as taking 36 plus 360, which is what, by the way? 396, which is one of these angles that they were listing. Okay. You're simply adding or subtracting one revolution. If you're talking degrees, it's just going to be 360. But technically, you have an infinite number of coterminal angles because there's nothing saying I have to stop at one revolution. Once I go one revolution past the angle, I could go a second time around. So I'll be adding 2 times 360. Or I could go 3 times 360. So see, I can continue to rotate as many times as I want. That's why we have an infinite number, right? Well, the same is going to be true in the other direction. Okay, so let me take this off right here. There we go. So let me go ahead and do this one. Do it in a different color. So let's say I go ahead and start again in standard position, but this time I'm going to rotate clockwise until I get around to that same terminal side. See, the terminal side stops in the exact same position, but they have different angle measures. This one has the effect of taking 36 and doing what? Subtracting 360. All right, which is what? Negative 324, again, which is one of the few they've got listed there. So like I said, typically I'm just going to go ahead and ask you to go ahead and find one positive and one negative. But you can go ahead and find, or I should say you can write an expression for every one that you could come across if you go ahead and take, in this case, theta, or whatever symbol you're wanting to represent your angle measure, and add 360 times n, where n is going to be an integer. Okay. Now remember, the integers were your positive counting numbers, 0, and they're what? They're opposites. So 1, -1, 2, -2, multiplying by 360 would have the same effect as what we were just doing. Okay. So let's take a look at the example they have here. Okay. So they have draw theta is equal to 220 degrees. Okay, so we start at 0. We have 90, 180, 270, and then we get all the way back around to 360. Okay, so what quadrant would 220 be in? Okay, definitely quadrant 3. And it goes counterclockwise as well, you know, quadrant 1, 2, 3, 4. So let's say this right here, starting in standard position and rotating around, that would be 220 degrees. Okay. So if I wanted to go ahead and write an expression for every coterminal angle that I could ever come across, well, I would take the angle I'm interested in, 220, and then add 360 times n. Remember where n is what? What's that z stand for? Integer, where n is an integer. Okay, but like I said, I'm just going to go ahead and most likely ask you for one positive and one negative, which is really easy because all you have to do is what? Okay. We're adding and subtracting what value? Remember 360 because that's one revolution. So let me go ahead and do this in red. Let's do the first one in red. So red will represent the positive coterminal angle. So I'm starting in standard position and I'm going to rotate around. But again, if I stop there, see I have 220 again, right? So to get back to it, I'm going to go all the way again, one more revolution. So this has the effect of taking 220 plus 360, which would be what? 580 degrees. So that would be the first positive coterminal angle with 220. So 580 degrees. Okay. And it's also the same thing. 1 is an integer, right? So that'd be the same as 220 plus 360 times 1. Okay. Now I want to go in the opposite direction. I want to rotate clockwise. Let me stick with purple. So here, I'm going to rotate around until I get to that terminal side. This has the same effect as taking 220 and doing what? Subtracting 360. Well, help me out here. What is the difference there? Negative 140. The negative is important, remember, because he tells you how to rotate. So negative 140 degrees. There we go. That's what it means to be coterminal. Okay, that would be the same as if I plugged in n equals -1. So -1 revolution. I went counter, or should be clockwise. Almost said counter. Okay. So any questions on coterminal angles? Does anybody want me to go ahead and give you another one? Okay. Then let's move on. Coterminal. Now we're going to talk about something called reference angles. Okay, reference angles are going to be really important to us when we get to the unit circle because they're going to help us create triangles that we can use and solve our trig functions with. Okay, so it says, given an angle in standard position, its reference angle is the acute angle formed by the terminal side of the given angle and the x-axis. And really that should say the closest x-axis. So either it's going to go ahead and create the angle with the negative or the positive x-axis, whichever one happens to be closest. And it's always the x. So let's say in this diagram here, the angle at the left is 210 degrees. Okay. And now I'm not looking for the coterminal. I don't want to make full revolutions in both directions. I just want to know the measure of the angle created using that terminal side and the closest x-axis. So if it's in quadrants 2 or 3, the closest x-axis is going to be the negative. Okay. What are you going to see in 1 and 4? Yeah, it'd be the positive x-axis. Stone. Oh, what you got? That's 30. That's right. Because think about it, we rotated all the way around to 210, but half a revolution is 180. Yeah. So that's going to be 30 degrees. Okay. Questions? All right, well, let's try a few of these down here. Draw each angle and state the reference angle. Okay, so 150 degrees. Joey, what quadrant would that be in? Not quadrant 4. Not quadrant 3. We're getting closer. Quadrant 2, there we go. Because remember, we start at 0. Then we have 90, 180, 270, and then we get all the way back around to 360 again. And can you have angle measures bigger than 360? Oh yeah, remember, we can continue to rotate as many times as we want. Okay, both counterclockwise and clockwise. So yeah, I'm going to say 150 is probably going to be right about here. 150 degrees. Again, so a reference angle is always created using the terminal side and the closest x-axis. So how far away from am I from 180? 30. So this reference angle would be 30 degrees, just like the previous one. Okay. Let's try 2B. 315. Abel, what quadrant would this one be in? The quadrants go counterclockwise 1, 2, 3, 4. It'll be in 4, yes. It's bigger than 270, but less than 360. So let's say this represents my terminal side. It's going to rotate all the way around. This is 315 degrees. So this is the first example where the reference angle is going to be created using the positive x-axis. We always use the terminal and the closest x. Okay, so Stone, what do you think? 45, yeah, 360 minus the 315, that would be 45 degrees. Is anybody having trouble with the reference angle? Okay. Well, let's try 2C. What's different about this one? Okay, it's negative. Now, because we're going to rotate clockwise, all those values are just going to reverse themselves. So if we start at 0, then this would be negative 90. This would be negative 180, negative 270 at the top, and then all the way back around to negative 360. Okay. Again, it's the same increments. You're just going the opposite direction because of the sign. Okay, so what quadrant would this one be in? It'd be in quadrant 3, yeah. The negative 120 is definitely between negative 90 and negative 180. So let's draw this angle right here. So we started in standard position. We rotated clockwise. That is negative 120 degrees. And now, using the closest x-axis and that terminal side. Now, the thing about the reference angle, it's always positive. Okay? So what do we think? What would be that reference angle? 60, that's exactly right. Be 60 degrees. Anybody having a hard time? Okay. All right, well, let's try this last one. 140 degrees. What quadrant's that in? 2. Okay. So let's say maybe like this. 140 degrees. Again, the reference angle uses the terminal side and the closest x. Okay, it is 40. That is exactly right. 180 minus the 140. Okay. Questions? All right, now let me give you a couple of different ones. Ones that are not on your paper, but it's really important to know this. Let's say I had a terminal side stop in quadrant 1. And let's go ahead and use the angle that we were first looking at, 36 degrees. Okay, what's its reference angle? It is 36 degrees. So in quadrant 1, an angle can be its own reference angle. Because remember, it's going to be created using the terminal side and the closest x-axis, right? Yeah, so this guy's reference angle would be 36 degrees. Is everybody okay with that? Okay. What if I rotated clockwise and had a negative 75 degree angle? What's its reference angle? It is 75, yes. Remember, the negative just tells me direction, and the reference angle is always positive. Perfect. Perfect, perfect. Any questions on reference? Any questions on coterminal? No? Okay. Then here is where the classes have been getting to today. This is our last idea. DMS, what we call degrees, minutes, seconds. So I'm not too worried about doing this by hand. In the grand scheme of things, there's more important things to go ahead and take a look at. I did go ahead and write out up here how it would be done if you wanted to go ahead and do that. So up here you'll notice we have degrees. 360 degrees is 1 revolution. We've been talking about that. Now, if you see a number with the 1 tick mark, that means minutes. So 1 degree is equal to 60 minutes. So what do you think the 2 tick marks are? Those are seconds. Okay, so 1 minute is 60 seconds. Okay, that makes sense. And then 1 degree is equal to 3,600 seconds. All right. So what we're going to want to do is convert DMS, a degrees, minutes, seconds expression, to decimal degrees and vice versa. Okay, well, we're going to use these ideas in the table above to help me out. Well, you'll notice the first thing I did, if you're going to do this by hand, the degree measurement stays the same. So like in this case, I just said 36 plus. But what did I do with the minutes? There you go. We know that 1 degree is equal to 60 minutes. We're wanting to convert that to degrees. So I took a ratio of the number of minutes to the 60. Okay? Plus, then I went ahead and took the seconds, which we were told up here, 1 degree is equal to 3,600 seconds. So I divided him by 3,600. I took the decimal value for each of those and then just took the sum. So the conversion is actually very straightforward. Is there anybody who has a question on that? Okay. Like I said, I'm not going to require you to do this by hand. I'm going to show you in just a second how to do it on the technology, but just in case anybody wanted to know. And who wouldn't, right? Exactly. Okay. Well, now let's say I want to reverse the process. So I'm starting with a decimal degree, this number here, 42.575, and I want to change it to degrees, minutes, seconds. Okay, it's just an alternate way of writing out the value. Well, you'll notice, what's my answer starting with? 42, which is exactly what I have prior to the decimal. When you're going from the decimal degree to DMS, you're only going to be working backwards from the decimal, the values that follow that decimal. So you'll notice the first thing I'm going to do is take the 0.575 degrees and I'm going to go ahead and convert it to minutes. See, we know that 1 degree is 60 minutes, but why did I write it like this? Why did I put 60 minutes over 1 degree? What am I hoping is going to cancel? The degrees, right? Because 0.75 is degrees, so I want those to cancel, so now I have minutes. Okay. So now you'll notice the value prior to the decimal is the number of minutes in my DMS. So now I've got to take the value following the decimal to go ahead and one more time convert to get my number of seconds. Is everybody okay with that? Okay. Well, you'll notice we have that 1 minute is 60 seconds. Well, again, why did I write it as 60 seconds over 1 minute? So what would cancel? Those minutes would cancel. See, now I have seconds. And that makes sense. 0.5 times 60, there's my 30. So here we go right here. Okay. Any questions on that by hand? Like I said, I'm not going to require you to do it. If I ask you to do that, you'll have a calculator. Okay. Or if you want a challenge, put the calculator to the side. Okay. Now, how do we do it on the calculator? Let me go ahead and show you that. So I want to take this DMS and I want to convert it. Okay. Oh, and I closed it for the previous class. Okay. Give me 1 second, maybe a few more seconds. Okay. Now, in order to do this, you want to be on your scratch pad. Okay. Now, you don't have your calculators with you right now. You'll have them tomorrow. If you want to practice this again, just let me know. But we need to go ahead and type in the degrees, minutes, seconds. That's all we do if we want to get the decimal degree. So it started off, I believe it was 36, right? Is that right? So 36. Now, everything can be found if you push Control and then this catalog button right here. Looks like the open book on your calculator. And it's going to give you all these great symbols, but you'll notice in the top right, there's your degree symbol. Now I'm going to go back. Okay, I'm going to type in, what was it, 25? 25 minutes? So 25, Control Catalog, and here in the second row, there's your tick mark. Okay, and now I'm going to type in 18 seconds. And we're just going to have to go in there twice for the 2 tick marks. Okay, so I typed in exactly what's on my paper, right? As soon as I push enter, it's going to give me this. Now, how do I convert that to a decimal? Control enter. And isn't that exactly what we were just looking at? 36.4217. Here is the only thing you have to be careful of. We're working with degrees, so your calculator has to be in degrees. If it's in radians, it's going to give you something completely different. So it's going to be real important to know what mode your calculator is in. And I'll go ahead and show you tomorrow how to change that. Okay. Now let's go back the other way. Let's say, what was it? And we have just enough time. The 42.575, right? Okay. Let's say we want to know what that is in degrees, minutes, seconds. 42.575. Well, this one's even easier. You're going to type it in. 42.575. Now, without hitting Control this time, you're going to type this catalog button. And it's going to bring this up with all these different tabs. You're going to want the tab on the far left. Okay. All these are alphabetical. See, mine is already pulling up because I had done this previously. So you want DMS. So as soon as I push enter, once I highlight that and choose it, it's basically telling the calculator, I want to take this decimal and rewrite it as degrees, minutes, seconds. When I push enter, 42 degrees, 34 minutes, 30 seconds. Okay. So this is one of those times where all you have to do is know the keystrokes and you are golden. Okay. That's all you got to do. Questions? Anybody having a hard time? Okay, then we'll go ahead and stop there because we are just about out of time.